In physics, we look at many different properties of matter, such as mass and velocity, acceleration, including energy. These are all properties of matter. We're going to look at a brand new property of matter. It's not brand new, but we're going to look at it. It's new to us, and it's known as momentum. Momentum, which we're going to use the symbol P. I really don't know why it's P. It might be Latin, it might be Greek, I'm not sure. Hey, if you find out, go ahead and post a video, a response to this video, and post it. I'm not sure how, I really don't know how this works. I just have my friend Alfred do everything for me. Since momentum is the amount of mass in movement, we can use the formula P is equal to m times v, or mass times velocity, which makes sense. If you have more mass or more velocity, you have more momentum. You have more amount of mass in movement. The units for momentum you should be able to figure out will be just a kilogram times a meters per second. It's no really fancy term for this kilogram meters per second. It's not like a name. It's not a Shep. I wish it would be, but it's not. It's just kilograms meters per second. So now we know that momentum is just mass times velocity. You take an object's mass times its velocity and you get its momentum. Now the question becomes, how do you change an object's momentum? Now, in order to change an object's momentum, you're going to need two things. You need some force. Use the force. And some time. Time! So to change an object's momentum, you're going to have to apply force and time. Force times time will give you a change in momentum. This change in momentum also has another name. It's called impulse. Impulse is just the amount of force applied to an object for a certain amount of time, or force times time. The same amount of impulse is equal to the change in the object's momentum. Impulse equals the change in momentum. Force times time equals mass times the change in velocity. So if impulse is force times time, then that means the units for impulse are, you know what? I'm not going to tell you. You got to figure it out. And you know what? That's going to be on the quiz tomorrow. So good luck on that. Figure out what the SI unit for impulse is using only fundamental units. So like seconds, meters, kilograms, not joules or newtons. Those aren't fundamental units. So have fun with that one. We experience impulse and change momentum all the time. In fact, in our next examples we're going to look at, they'll show real world examples of why some things hurt and some things don't. So imagine you have an average baseball about 145 grams, which is 0.145 kilograms, and you chuck this baseball about 90 miles per hour. That's about 40 meters per second. So if you imagine you have this baseball, this 0.145 kilogram baseball traveling at 40 meters per second, that means it has momentum of about 5.8 kilograms meters per second. If you catch this baseball, it will have momentum of 0 kilograms meters per second because it's not moving. Zero velocity times any mass gives you no momentum. Okay, well, then that only makes sense that the change momentum is 5.8 kilograms meters per second. It had 5.8 kilograms meters per second, then it went to 0, so the change is 5.8 kilograms meters per second. Now notice, no matter how you catch this baseball, the change in momentum for this baseball is going to be 5.8 kilograms times meters per second. It will always be that because it's always starting at the starting speed and ending at the final speed of 0. But depending how you catch the baseball is going to change the amount of force exerted on your hand. Let's take a look. Now let's say that you have stopped the baseball in 1/100th of a second. So the amount of time that you exerted a force on the baseball is 0.01 seconds. So if the change in momentum is 5.8 kilograms meters per second, and you know the time, then just take the change in momentum, divide by time to give you your force. If it took you 0.01 seconds to stop the baseball, then you would have about 580 newtons exerted on your hand. Ah, my hand! That's a lot of force exerted on your hand. But let's say that you don't just stop the baseball real quick. Let's say you actually follow the baseball through and increase the time that it takes for your force to stop the baseball. Let's say it only takes half a second to stop the baseball instead of 1/100th of a second. Do the math quickly to figure out how much force that would take. Go ahead, I'll wait. Your room's really messy. You should probably clean up a little. Using the change in momentum divided by time, using 5.8 kilograms meters per second divided by 0.5 seconds, you should get about a force of 11.6 newtons. That's a lot less compared to 580 newtons. We can see this with a lot of different safety regulations, like airbags. If you think about it, an airbag is supposed to take a lot longer to stop your face compared to the steering wheel. If the steering wheel takes a much shorter time, that means there's much more force on your face compared to the airbag. Impulse. It's cool. Now, it's time for some examples.